Hey everyone, this is Muhammad Nadeem and welcome to my YouTube channel. Today in this video, we will discuss that what are equipotential lines and equipotential surfaces. So let's start the video. In this simulation, we have five positive charges, and these five charges are surrounded by large number of electric field lines. So here these arrows are electric field lines, and the magnitude of these arrows represent the strength of electric field, and the direction represent the direction at which the test charge will move. In this picture, let's positive charge is present here at the center. I'm going to label that. So let's let's the positive charge is present here at the center, and I take a small portion of that sphere. So this is actually the single portion of the sphere. So if I take a single step from the center, there will be a sphere formed around that positive charges, and this sphere is formed will have the same distance r. So here this sphere will present at the distance r from this positive charge, and the combination of all points in 3D here around this positive charge, and these points will have same strength of electric field. In other words, we can say that these all points will have the same voltage. Therefore, therefore the surfaces which is formed by the combination of the points which are present at the same distance from this positive charge, we call that surface as equipotential surface. So as we saw before, that if we take even a single step away from this positive charge, there will be some other combination of points. So here, if I take a single differential step here, ds, if I take this ds, then the other sphere is formed from this positive charge. So the surface, this is actually the surface of the sphere, and the points which form this surface of the sphere, the points which form this surface will have the same strength of electric field and also the same voltage, because these all points are present at the same distance 2r from this positive charge. So in the first case, the sphere was formed at the distance r from this positive charge. Now this sphere is formed with the distance is 2r from this positive charge. So therefore the combination of all these points which form a surface around this positive charges will have the same strength of electric field and voltage. Therefore we call these surface which is formed by the combination of these points, which we will call that is equipotential surface. So if we further take the next step, now the radius of this third sphere will be 3r, mean that this sphere is present at the distance 3r from this central positive charges, and this sphere is actually the combination of a large number of points in electric fields which have the same electric field strength and also the same voltage. So these points have the same voltage. Therefore these points which form the surface at the same 3r around this positive charge, we call them as equipotential surfaces. Similarly, if I take the next step from this surface, another surface will be formed, and now in this case the distance the distance from this positive charge, which is actually I'm going to extend then this. So this is actually, we have a positive charge, and this is let's say we have a positive charge, and now the distance from this positive charge to the next sphere, here we have this sphere, this is now become 4r. So all points around this positive charge which are in the 3D form. Here these all points will have the same distance around this positive charges. So here are all that combination of the points. So that combination of the points make the surface around this positive charge in 3D. We call them as equipotential surfaces. So therefore, we take next step. Then we take the next step, and there will be some equipotential surfaces around this positive charge, and if we increase the distance r, then there will be the other surface around this positive charge, and then in the similar way we will take a step away from this positive charge, and for each step there will be the equipotential surfaces, and the surface is actually formed by the combination of large number of the points in the field of the charge which is present at the center. So the combination of all these points in the space or in the field will have the same potential, will have the same field strength, and also have the same voltage. Therefore, the combination of all that points in the form of surface, we call them as equipotential surface. Similarly, we take the other step and other step, and we reach here. This is the last sphere, the last surface. This is the last surface around this positive charge. So this is actually extended at the 3D around this positive charge. So here it will make just such like a shape. And let's consider this surface is the surface of the ball. So yeah, this is actually the surface of the ball, and each point on this surface. So let's say I consider this point which will be present at the same distance from this positive charge, and I also consider this point which will be present at the same distance from this positive charge, and similarly I consider all these points, and each point will be present at the same distance from the charge which is present at the center. Every point on the surface will have the same field strength. They will have the same field strength. Field strength, as we discussed before, each point in the electric field will have a magnitude and direction. So these points on the same distance from this positive charge will have same field strength, and also the same voltage. So there's combination of the points on the surface of this on this surface will have the same voltage as well. So voltage mean these points will have same potential. So we can say that their points will have the same potential, and therefore we call them as equipotential. Potential surfaces. So that surface is called equipotential surface.